All right, everybody, here's the next video on the next bit of information. But before we start, just kind of a couple reminders here. Just a reminder that you have a test on solutions. All right, that test opened this morning about 8 a.m. And again, you have a 90-minute time limit. You need to complete that before you move on to this next information. So if you haven't already taken that test, you need to go back and do that first. All right. The other thing, this is possibly the last unit for the year. We'll finish acids and bases over the next 5 weeks or so. I think we have 6 weeks counting the week of finals. I have no idea what is being told to us from the district office regarding the final exams at the end, but we will continue to play with that as we go. This crisis learning is way different than what we've been doing in the classroom. So I was also told that I've probably been giving a little bit too much work each week. So I'm going to calm down just a little bit. We'll go really slow through this last unit. Today's lecture will go through like an introduction on acids and bases. And then from there, you'll have one homework assignment based on this. We'll do a little bit more next week. All right. This unit does have some real life connections. So as we get started, a couple things to notice about what's on the screen there. You'll see baking soda and toothpaste, drain cleaner, batteries, lemons, soda, tomatoes, any foods really are going to be considered either an acid or a base. As we go through this, you're going to be able to explain why some things happen in real life and why some things are just crazy and weird and what's going on. So as we get through this, hopefully you'll start to understand what we're talking about. All right. And like I said, everything that's in Moodle is still open. I'll come back and do some wrap up here at the end. That didn't do what I wanted it to do. Let's try. There. All right. So acids and bases, here's some things to know about. These are very important substances that we deal with. Like I said, most foods and a lot of the other substances that we use in our world, like things that they use in the medical field to try to determine what's going on with this virus, they are using acids and bases for those as well. All right. An acid is defined by a couple things we'll talk about, but things to keep in mind is they taste sour. So Sour Patch Kids, vinegar, any of your citrus fruits, those things that taste sour tend to have citric acid in them. Stomach acid is an acid, obviously. Soda pop, like when you drink a cola, a Coke, or a Pepsi or whatever, it has carbon dioxide in it, and that carbon dioxide makes the solution slightly acidic. And then when you drink it, it actually has a chemical reaction with your tongue that will, like, you don't feel it, but that's part of what we talk about when we're having soda, is that bite of the soda, and then the sweetness on top of it makes it taste good. It's kind of crazy. That's acids. Bases, however, are a little bit different. They taste bitter, and they are slippery. So soap, drain cleaners, any cleaners for that matter, things like Windex, things that you use to clean the floor, a lot of time are basic. There are a few cleaners that are slightly acidic because it needs to dissolve something like the water deposits that were on your sink or around the bathtub, things like that. Those might be acidic. The other good thing about bitter is poisons are often bitter in taste, and that's something that nature or whatever natural selection, the way God made it, whichever way you want to subscribe to, has made it so that those poisons have that bitter taste, and you do not want to eat them because you're like, oh, this is gross, I don't want this anymore. Another term for acids and bases are called alkaline substances. So these definitions have come from two different walks of study. Svante Arrhenius was the first guy to come up with acids. He came up with this a long time ago. I want to say it was like the mid to early 1600s, maybe early 1700s. Now I can't remember, and I didn't write it down. But Svante Arrhenius, so we named them after him, Arrhenius acids and Arrhenius bases. The other model was developed by two people kind of at the same time, but separately. Bronsted was Johannes Bronsted. He was a Danish guy. He's from Denmark. And Thomas Lowry was the other guy. They were working in their own individual laboratories, and they came up with the same conclusion at about the same time. So we call these acids and bases Bronsted-Lowry acids and bases. So what does that mean? A acid, based on Arrhenius's definition, was that an acid will produce a hydrogen ion in aqueous solution. So what does that mean to produce hydrogen ion? So hydrogen ions, you might remember as being, let's see if I can do this, as being H+, right? So H+. That would be a hydrogen ion. You agree? You should. I'm going to erase that now. Because if hydrochloric acid were to dissolve in water, it would produce an H plus ion. This that you can see right here. Okay, hydrogen ion in solution. So acids produce hydrogen ions. His definition of a base was that it will produce hydroxide ions. So according to this definition, the only things that are bases are hydroxides. It looks like this. If we were to put sodium hydroxide into water, it splits apart, it dissolves into the ions. We get sodium ions, and then we also get these hydroxide ions. All right. So hydroxide ions for Arrhenius base, hydrogen ion for Arrhenius acid. That is literally the definition of those things. So if it says which substances produce hydrogen ions in solution, that would be called an Arrhenius acid. Which substances produce hydroxide ions in aqueous solution? That is called an Arrhenius base. Bronsted-Lowry saw that there were a lot of things that acted like acids and bases that did not fit the definition that Arrhenius had come up with. So Bronsted and Lowry said this. They said acids are proton donors. And he said that they said that bases are proton acceptors. So if we go back and look at this, these little guys up here, these hydrogens, technically an H plus is a proton, right? So if I have a hydrogen atom, what is a hydrogen? Well, hydrogen has one proton and one electron. If we remove the electron and all we have is a proton, then we have a hydrogen ion. So to be a proton donor, it means that it is producing an H plus ion in the solution. It sounds weird. They mean the exact same thing, but there's way above the level of this class, there's an exception to what's going on with those things. So we're just going to ignore that for now. Being a proton acceptor, all it means is that substance has the ability for this proton that we just talked about, this little proton right here, to be able to stick on to something else. If that thing can stick on somewhere else, it's a proton acceptor and it's a base. All right. There's other things that we're going to talk about both in this lecture and as we continue down the road for the next couple of weeks. All right. So with Bronsted-Lowry, they came up with this plan and this idea of how do we look at these acids and bases. And there is something called a conjugate pair. So conjugate pairs are two things that are related because one has donated and one has accepted a single proton. Literally, all we are saying is these two things are different by one hydrogen atom, or one hydrogen ion, actually. So if we were to look at a formula like this, HA being some acid, it doesn't matter which acid we're talking about. If you remember from the first semester, all acids begin with H+, right? So H+ being the cation, A- right there being the anion. I'm going to sneeze. If I do, pardon me, I'm sorry. So the H is the proton, the A- is the anion, and it is going to be a proton donor. The water is going to be a proton acceptor, okay? And now I made a smiley face. So water is going to be a proton acceptor. So now here's what really happens. The acid donates an H to the base, and it produces hydrogen ion in water, which becomes this thing called a hydronium ion, which we'll come back to later, and the A- is left over. If you'll notice that the conjugate pairs, the acid and the conjugate base, and the base and the conjugate acid, those are the pairs, they differ by one H+. So this is my acid, and it connects to the conjugate base, and they differ by one H+. The other is true as well. The base and the conjugate acid are different by one H+. H2O and H3O+. The difference is an H+ on the conjugate acid. So as we continue to work through these, that's literally how hard it is to know which two things are conjugate pairs, is you're looking for those that have a different in one H+. If there's more than one H different, then they're not conjugate pairs. So like H2O and H+, those are not conjugate pairs because they are not different by one H+. Okay? So yeah. The other thing that you'll see is there is a difference in these terms called strong and weak acids and bases. For right now, let's just focus on just acids. So if we said that is a strong acid or that is a weak acid, it has nothing to do with what happens when it touches skin, when it touches metal, when it does any of those things. It has to do with what happens when I put that stuff into water. Does it completely dissociate into ions? If it doesn't dissociate into ions, then it is not a strong acid. I can go to school and I can go into the back stock room and I can grab a solution that is considered a weak acid. And if I were to pour it onto my hand or your arm or something, it would cause immediate major damage because it is highly concentrated acid, even though it's a weak acid. What we mean is if I were to dissolve that into water, it would not become ions. Okay, there's no ions. That's that term dissociation, is becoming ions. So strong substances, strong acid or strong base, will completely dissociate and they will conduct electricity in that solution. If we were to try to run electricity through it, it would pass the electricity. Okay. For our time in this class, for what we're going to be dealing with, you may hear in other textbooks and when you get to AP chemistry or college chemistry, sometimes they say there are 6, sometimes people say there are 8. I could list all 8 of them, but for us it's not important. These 4 strong acids are the only ones you need to be aware of. They are hydrochloric acid, HCl. They are nitric acid, HNO3. There's one that's very uncommon in terms of what we use at schools. It's called perchloric acid, HClO4, but it is a strong acid. And then the one that's the most prevalent in all of industry in everything we do in the United States is sulfuric acid, H2SO4. H2SO4 is used for like 95% of all of the industrial apparatus things that we do in the world. Let's see if I can get this to work again. When it loses one H, it becomes this, and I can't write with my mouse very well. It becomes HSO4 with a -1 charge. Can you see that that is going to be a conjugate base? The acid is the H2SO4. Let's see if I can get this to work again. I just want it to be able to where I can underline. Okay, H2SO4, this would be the acid, and if we lost one H, it's HSO4 with a minus charge. This would be the acid, the H2SO4 acid, HSO4 minus conjugate base. It is a strong acid for that first dissociation. All right, again, that's a lot of information that you're not going to understand yet, but maybe later in the unit that'll come back to it and we'll make some more sense out of it. All right, so now, there are some substances that are both acids and bases depending on their conditions. This has a term, it's called an amphoteric or amphoprotic substance. Water is one of those examples, okay? Water can be an acid under the right conditions, and it can be a base under other conditions. So it's called amphoteric, all right? I can't get comfortable in my chair, sorry. So finally, these things called amphoprotic, I might show you a little bit more about them using the conjugate pair thing like next week, but I'm not 100% sure about that. All right. Another thing we need to talk about is how we describe something's acidity or its basicity. How much of an acid or how much of a base is it? And we use something you've probably heard of called pH. They've started selling this like pH water and all kinds of stuff where it's slightly basic. I've never tried it, but I have a feeling it's got a little bit more of a bitter taste to it because it is slightly basic. But ultimately, here's what it comes down to. There's a huge, it's not extremely complicated, but it's pretty complicated calculation that you'll require to use your Algebra 2 skills. We're going to be using logarithms. So I will wait and explain this maybe next week or the week after that of how we actually calculate pH using logs, all right? But here's what you do need to be aware of. A pH of 7 is neutral. Technically, letter of the law, anything less than 7, 6.9 is a base. Sorry, I said that wrong. Less than 7 is acidic, according to the letter of the law. But most of us would say if it's between like 6.4 and 7.6, that's our window of being neutral. 6.5, 7.5, and in between, that's neutral, right? If you were to take something like coffee, it's going to have a pH of like 6.1. It's only slightly acidic. If you take lemon juice, it's going to be like 2.5. And if you use vinegar, it's like 2 of the pH. They are definitely acidic. Bases have a pH above 7. So if you were to take drain cleaner and test its pH, it would be like 13.5. If you took Windex, it'd be like 11. Some other things that are bases are definitely in that like above 10 is definitely a base, right? These things you need to be aware of. We'll come back to them and talk more about them next week, but at least introduction wise, that's what you need to be aware of. All right. So a couple things to go on. After this little thing here, you should be able to, this lecture, you should be able to complete the one assignment that's in Moodle titled Acids and Bases, or Acids and Base Intro, right? You have one assignment. I think I gave you 5 attempts. It's not going to tell you the correct answers, but it will do the adaptive mode, where if you click on the check button, it will tell you if you got it right or wrong. And you have 5 attempts, so you can go through it, see if you get them right. You lose some points, retry the whole thing, you'll know what the correct answers are, and you'll be able to get 100%, right? The other thing is this coming week, I hope to be able to do another virtual lab similar to what you did on the solutions on that FET activity the other day. The virtual labs are easier for all of us. I don't have to go into the classroom and try to take stuff home with me and do a lab. And hopefully I'll be able to find something for you on acids and bases. And finally, if you do anything from the previous time in our class, everything all semester since January 13th is unlocked and open in Moodle. So you can do any of those and email me. All of the stuff that we've been doing since we started doing distance learning is all available as well. And the school has asked us to be pretty lenient on accepting late work. So what's going to happen is anything that you turn into me late since we started distance learning, so anything since March 30th, April 1st, somewhere around there, any of those assignments that you complete, you'll need to email me to tell me that you did it. And I will still give you full credit for whatever you've done, even if it's late. Some of you never did the makeup tests. If you need to still do one of those makeup tests, please send me an email. I'm going to be more than happy to help you out with that. I want you guys to learn this material and be able to help your grade. All right. So those makeup assignments are still available. You can keep working on all of those. As we continue to move forward, I'm going to try to do as best as I can to make it simple. I will still be on Google Meet on Tuesday mornings from 10 a.m. until noon. And every Friday, I'm in front of my computer to reply immediately to emails. If you want to do a Google Meet on a Friday morning, I'm available to do that. And you can definitely hit me up for those things, all right? So to wrap it up, things that you should do this week. You need to review and be ready to take the exam. If you do all 6 of the solution assignments, you should have no problem passing that little test, okay? You should also then take the test. So you have solutions 1 to 6 that you need to finish, the solutions test that you need to take, and then after you've watched this video and taken notes as you need to, then there is one assignment called acids and bases. And then next week, I hope to find a virtual lab for you guys to work on. I hope you're all doing well. This crisis is crazy. It's so weird. I hope that you're getting to go outside a little bit, get some fresh air, go for a walk, do something, because the fresh air will help you clear your mind and help you to feel better about yourselves. I'm glad that you guys are still with me. If you have any issues or you have anything that you need help with, please, please, please let me know. Send me an email. I have a lot of resources available, and I'm more than happy to help you guys out. If you have any other questions, send me an email. I miss you guys and hope to talk to you soon. Bye-bye.